Hi everyone, this is the medium set of circles for SAT practice. So we have a circle here with points A and B. The measure of ACB, this angle here, is 120 degrees. If the area of the circle is 81 pi, what is the length of the minor arc? So basically I want to find out what our ratios are. And first I'm going to find R, so because I have to set up a proportion. So I have the area of the circle is 81 pi. So 81 pi equals 2 pi, not 2 pi, but just pi r squared. And the pi's cancel, so 81 equals r squared, so r equals 9. So that's 9. Not that we need that, we just need the circumference. So the circumference equals 2 pi r. So that's going to be 2 times 9 is 18 pi. Alright, so that's the circumference of the whole thing. So, and now we want to get a ratio here. So we know this is 120. So 120 over 360 degrees equals 1/3. So if I want to take the circumference of this, all I have to do, so I want the length of this minor arc here, I'm just going to divide my circumference by 3. So 18 divided by 3 is going to equal 6 pi, 18 pi. And that is, oh, here it is. Your answer is A. Okay, next one. Now this one they don't draw the circle for you. So they just say circle C is drawn on a coordinate plane center at the origin. If point AB lies on the circumference of the circle, what is the radius of the circle? Basically, we're just going to use basic algebra on it. You know that the equation of a circle centered at the origin is given by x squared plus y squared equals r squared. And therefore, where x and y represents any ordered pair point that lies on the circumference of the circle, and r is the length of the radius. So all we're going to do is separate, instead of x and y, we're going to separate it with a and b. So we get a squared plus b squared equals r squared. So r equals the square root of a squared plus b squared. And it had to be extra choice, but I forgot to write them down. But anyway, this is your answer. Okay, so it's pretty easy actually, especially if you know your formulas, your standard form of your circle with center at 0, 0. Alright, here's number 5. So we have some of the advice you might need to know is that the two legs of this triangle X, O, Y are both radii of the circle and therefore have the same length. Because this is a radius, this is a radius, so they have the same length. So we're going to use this fact to link between the formulas. We know that the area of a triangle, need the area of the circle, the area of the triangle equals 1/2 base times height. Okay, and the area of the triangle x 0y is 25. So we have 25 equals 1/2 base times height. So when you multiply both sides by 2, you get 50 equals base times height. Well, these two are the same. So, and they're the radius. So I could just call this r times r, which is r squared. And then so r equals the square root of 50, which is 25 times 2, which is 5 square root of 2. Now, we're going to substitute this value into the formula for r squared. So, for the area of the circle. So the area of the circle is pi r squared. We know that r squared is 50, so the area of the circle is 50 pi, and that's your answer. The answer is going to be C. We didn't even have to do this part. When I did this, that was just extra. I didn't need to do. Okay, next we have 3 shaded regions here, and there's semicircles actually, and they give you all this information. So basically, we want to know that we're going to use the only diameter given, which is AB equals 4. So this is AB equals 4. And then determine the other 2 diameters. So once there, then we're going to use the area formula to find the area of each, and multiply each area by 1/2 to account for the fact that you only have a semicircle. So basically, let's start. The diameter of the semicircle AB is given as 4, so its radius is 2. Okay? Therefore, the area of the semicircle is AB. The area of this, the area of AB, let me write it this way. Area of AB, semicircle, is 1/2, because we're only doing half of the area, pi times 2 squared. So the area of AB equals 2 pi. So 1/2 of 4 there. Now, if BC is 2AB, then BC is 8. Because 2 times this, so this is going to be 8. And the radius, therefore, will be 4. So the area of BC, the radius is 4 here, is 1/2 pi 4 squared, which is 8 pi. So now we have the area of AB and the area of BC, the semicircle. And then the next thing that is given is, so the next thing we're given is that CD is 2AB, and so 2 times 4 is 8. So we're doing the last one. The area of CD equals 1/2 pi times 8 squared, which is 1/2 of 64, which is 32 pi. And that's that area. So we have our 3 areas, and then all you have to do is add all these up. 2 pi plus 8 pi plus 32 pi, and that equals 42 pi, which equals B. It's matching B. Okay, and the last ones, we have a semicircle shown at point Q, and if the measure of the central angle of the shaded sector is 160 degrees, what is the value of X? So basically, the half of a circle, a whole circle has 360 degrees, so for a semicircle, it's 180. So basically, you just subtract 160 from that, and you get 20 degrees. And then to convert to radians, you just do 20 degrees times pi over 180. And that cancels. So you get 2 pi over 18, which gives you pi over 9. So your answer is C. Okay, the next set we're going to do is the hard ones for SAT practice. Thank you and have a nice day. Bye-bye.